Okay, this video that we are taking is not actually a lesson being done in class, so there will be no questions being given or asked. When we did this lesson, remember that the recording didn't work. So this is me simply going over how to actually convert mixed radicals to entire radicals. We'll start with question A. So, there's a few things we need to remember before we do anything. Mixed radical form and entire radical form. This is considered mixed radical form because it has a coefficient in the front, the A. This other one is entire radical form. We call it that because there is no coefficient. So, when we're doing these questions, we're trying to lead from here to there. Seems simple. So, question A. We're trying to get that 3 underneath the square root sign. We know after we convert that we're still going to have a square root sign. So we can just write our square root sign right in there. We also know that this number 14, we don't have to do anything to it because it's already underneath the square root sign, just like we want it. So we just leave it under there. Now the 3, the coefficient right here. That's where our problem's going to come from. We need to get that underneath the square root sign. So let's just take it right there and draw it in. We're going to put brackets around it. And we're going to put brackets around it because that helps us in the future anytime there's a negative number. If you always use brackets, it's safe. Now, we brought it underneath. But because we brought it underneath, we have to do something to it. We can't simply just move things around or else they're not equal to each other anymore. So when we bring that 3 down underneath the root sign, we need to take whatever the index is here, and since there is no index here, it's a 2, we need to also put it here. So, the index is 2. That means we have 3 squared underneath that. Once we finish all that, we do 3 squared times 14. And that'll give us our final answer. So, 14, 3 squared is equal to 9. And then your final answer should be the square root of 14 times 9. That will give you your entire radical, and that will give you your final answer. So, 14 times 9 is just 126. Right there. We box our final answer so that it sticks out on a test or anything else. B is the exact same, but if we look over to the question C, we see that there's a little bit of a trick. We see we've got a negative here. And that negative is going to cause us a problem. So erase a little line over there. Now, we've got negative 5 root 7, square root 7. We want to go from mixed to entire, so we know that our root sign is not going anywhere. So let's just draw it back up. We're looking to get into entire radical. We know there's going to be a square root sign. That 7, it's already underneath the square root sign, so we don't need to touch it. Now, the 5. We bring it back around. And we put it underneath the root sign. And we use brackets. And this is the reason we use brackets, because there's a negative sign in front of that 5. Right there. That negative also needs to come with the 5. Now, there's one more trick. We have to do something to that 5. We bring that negative 5 underneath the root sign. We can't just leave it there without doing something to it. So we need to put it to the power of 2 because the index is equal to 2. If the index was equal to 3, we would have to put it to the power of 3. Again, do your simple computation. So you can get the square root of 7 times 25. It's 25 because negative 5 times negative 5 gives you a positive. 7 times 25 gives you the square root of 175. Now, we had some good questions. I remember this from when we were in class. We should always be able to punch in this original part here and this part here, the square root of 175, and they should equal each other. If they don't equal each other, that means we didn't convert them properly. Now the question was, when we do the square root of 7 and we multiply it by 5, what do we get? Well, we got 7 square root times 5 gave us, times negative 5, sorry, gave us negative 13.2 ... It keeps going. It's an irrational number. Now, if we do the square root of 175, what do we see we get? We get, our calculators tell us we got 13.2 ... The same dots. Now, there's no negative sign. So you're saying that can't possibly be the same. We have a negative sign in this answer, and we have no negative sign in this one. But remember from our other lesson that every time you take the square root of something, it produces a positive and a negative. But our calculators often only show us the positive answer. So it actually is negative. You'd have to put the negative in there. So this is a proper conversion. We did it right. Okay. Now let's jump down and let's do question D. Let's just erase all this. D. We're going to do D up here because we're going to do it above instead of below because we run out of room. Okay, we're converting. We want it to be an entire radical. So we know that the radical, it's not going to change. We put the radical sign in. But there's something different about this one. It's not a square root, it's a cube root. And when we convert, we still want it to be a cube root. So include your index of 3 still. The radicand is 3. It's already under the cube root sign, so we don't need to mess with it. The 2, let's bring it up in here. And we're going to use brackets again. Now here's the trick. When we were doing cube roots before, or square roots before, we were squaring things when we brought them underneath. We're doing a cube root this time, so we need to make sure that we cube the coefficient when we brought it under. So this is a 3. Again, the good trick to remember is that number should equal that number. If your index and the power you raise it to aren't the same, it's probably something's off. After that, you just have to do your simple calculations. So if you do 2 cubed, you should get 8. Then if you do the rest of the question, 3 times 8, and then you do the cube root, 3 times 8 is 24. That's your final answer. Every box. Let's do E together. E has another trick. We see over here our coefficient. Our coefficient is a fraction, and we've never seen that before, so we need to figure out what we're going to do with this. We're trying to convert it to an entire, so our steps are still the same at the beginning. We do a cube root. We know it's going to be a cube root because we don't want that to change. Our 80 stays the same. Now, how are we going to bring a fraction underneath? It's a good question. So what we need to do is we need to take that fraction and we treat it the exact same. We're going to put it in brackets and we're going to just move it right on up there. So brackets 1 over 2. We treat it the exact same. It's still a coefficient, so we still treat it the same. What power do we have to raise it to? We have to raise it to the power of 3 because the index is 3. All to the power of 3. Now, 1/2 to the power of 3 probably looks a little scary to most people. So let's write a little trick up here on the top. When we have a fraction that is being raised to the power of something, so we have 1/2 to the power of 3. That 3 applies to both the numerator and the denominator. It applies to both numbers. So we could simply change it to say this. And then it's not so scary. So let's do that with our own answer. This becomes 3 cube root 80 times 1 cubed over 2 cubed. Just like we got from up there with our little trick up here. Now that's easy. What's 1 cubed? Well, 1 cubed is just 2, or it's just 1. It's just 1, I'm pretty sure. And 2 cubed is 8. So this can be written as the cube root of 80 times 1 over 8. Now if you do 80 times 1 over 8, you should just get 10. Remember, there's 2 ways to do that. You can do 80 times 1/8, or you can do 80 divided by 8. That works better for some people. It all depends how you want to see it. Once you do that, your final answer, it should be the cube root of 10. Converting mixed to entire, most people find a little bit easier, but sometimes it can be tricky to remember all the little things. Quick review. Your index here should be equal to your index here still. That never changed anything. A lot of people will lose that number at some point, and it's important that we don't. Okay, finally, let's do F. We're going to clear our board here. So we have quite the mess. Okay, F. We have a negative coefficient again, and with a cube root. So this kind of gives us all of our tricks. We know we want to end up with the cube root again. So let's write it out. That's the first thing we write. We know when we convert our goal, we still want a cube root. The 7, it's already under the root side, so just let it be. The -4, that's our tricky part. So we want to bring it over to the top, and to do that, we need brackets. Bracket -4. Remember, the negative comes with the 4. It's attached to it. So they both have to come in underneath that bracket. Again, we can't move a coefficient underneath the root sign unless we do something to it. What we have to do to it is raise it to the power of whatever the index is. Index is 3. The power up here has to be 3. After that, it's all about just doing some quick calculations. If you do -4 cubed, you should find that it comes out to be -64. One more quick calculation, you multiply that by 7, you'll get it's the cube root of -448. Can we do the cube root? negative numbers? It was a good question that we also had, because you can't do the square root of negative numbers, but you can do the cube root. Because it's possible to multiply 3 negative numbers by themselves and get a negative product. We couldn't do the square root of negative numbers because there's no combination of two numbers that could multiply together that are the exact same that would give you a negative number. That concludes converting mixed radicals into entire radicals.